Welcome to the edge, the cutting edge of the future. Ford's future, and your future. At the Nashville glass plant, nothing stands still. The UAW and Ford are running to meet the future, and to meet it with state-of-the-art technology. Advanced automation sets the pace for efficient, safe production. And when it comes to quality production, nothing stands in our way. Continuous production means we succeed in meeting the demand for our products all day, every day. At Ford, quality is job number one. To the UAW and Ford, product equals quality. On that, we stake our reputation. With a wide range of superior products, we've got what it takes to meet and beat the competition. And the payoff? Millions of satisfied Ford customers and the pride of a job well done. At Nashville Glass Plant, our people make it happen. The UAW and Ford believe that you are our greatest asset, because all of you contribute to the company's success. By training and developing our people well, we know we're investing in the greatest of all resources, people. People with commitment to quality. People working shoulder to shoulder as a team. People with the spirit to win and to meet the challenge of tomorrow. Advanced technology, superior product, the enormous contribution of our people, these are what make Ford Glass Plant great and put us on the cutting edge of a brilliant future.
An orientation to the plant and production processes at Ford's Nashville Glass Plant begins with the most visible elements of the skyline. These stacks mark the beginning of the 3 glass-making furnaces where the raw materials are heated into molten glass. Behind the plant, over 3,000 rail cars of materials are used each year. The primary materials, sand, dolomite, and soda ash, are carried by conveyor to a mixing facility called the batch house. The word batch refers to the mixing procedure. Each ingredient is loaded into a series of containers by weight. The containers are emptied onto a conveyor. And the ingredients are carried to a mixer. The final mix is carried on a cable-driven rail system. The container is called a hopper. The hopper is pulled up 3 stories and changes to a monorail system to travel over to the furnace area in the main plant building. This glass is called cullet. Cullet originally referred to trimmings in the glassblowing process in 18th century France. Today, cullet is produced in the cutting operations. This trim and all broken or damaged glass products are fed into a conveyor system and carried to the batch house. Remember that cullet is valuable and remelted. Do not mix trash into our glass products. Up to 50% of the batch is cullet because the glass chips melt at a much lower temperature than sand. This allows the furnace to run at a cooler temperature, which extends the time between overhauls and lowers energy cost. This hot end area is only the beginning of the furnace. The furnace area departments are in the 400 series numbers. The furnace is a continuous processor that extends over half the length of the plant. The liquid glass floats out of the furnace onto a pool of molten tin. The glass is now a continuous sheet as wide as the furnace. Cogwheels keep the glass stretched across the furnace. The sheet of glass is pulled forward by rollers as it cools. Inspectors watch the continuous stream of glass. Laser inspection is also used. The diagonal run of the cutters match the speed of the line and produce a straight cut. The end of the line is known as capping because each load is capped when full. Again, for reference, we'll return to the capping area. There are 2 product groups, windows for buildings and windows for cars. Glass for buildings is a finished product and is crated for shipment. We produce over 350 million square feet of these products a year. The 3 float furnaces and the storage area for building glass take up nearly half of the floor space. Automotive glass is divided into the 3 window areas of the car: front, back, and side glass. The 3rd automotive product area is side glass or body glass, and the departments are in the 500 series numbers. They have 8 cut and grind lines. They have 5 separate leers. This group handles 16 products at one time. Cut and grind lines 3 and 4 are paired and are similar to 6 and 7. To understand the production flow, we'll follow a piece of glass as it moves through the system. The finished template is transferred to the hole drill station, which is an automated drill press. You can see 4 final transfer units here feeding this washer conveyor. There are 4 operations like the one we just saw clustered around this washer conveyor, producing 4 different products. The 4 parts are packed in different boxes. We consider this 2 lines, and they are numbered in the packing area for reference. Right behind them is an identical operation feeding a central washer conveyor. Behind them is the paint room for body glass. There are 3 more lines in this area next to the wall of the cafeteria. These 2 lines are manual. The glass is carried vertically down the line. The lines are back to back. The manual system scores the bracket or glass stock by hand, and the trim is broken off by hand. The seaming and hole drill require manual transfer. Next is a hybrid line. It uses the same arrangement as the automated lines and uses the conveyor system of the manual lines. This was the first automated line at the plant. Around the corner, all of the Department 500 Lears are found. The first is a press form Lear. The tongs are preheated. The parts are preheated. This is a gas Lear with burners in the walls. At the end of the Lear, the parts are pressed into the mold shape and quenched by cool air. This is Lear number 2, a gas-fired furnace. Forced air lifts the glass off the slide and the chain pulls it through the Lear. The gas burners are in the roof. This bend was developed gradually into this final curve in the Lear. The Lear next to it is controlled by computer. The newest line in the plant is also part of the 500 department. The 600 series departments produce backlights or back windows. The line begins off of the main aisle at column D57. From beginning to end, a backlight takes 8 minutes to go through the line. This was the first continuous operation line at the Nashville glass plant. It uses the NC or numerically controlled cutter and the flame stripping. The 4 arms load and unload the templates into the Sun Tool grinders. The Sun Tool grinds the edge down to a beveled satin finish. The coolant liquid keeps the diamond cutting wheels from burning. The line has hole drill equipment not required for this particular product. The washer prepares the template for the paint room. The silkscreen process is used. The special paint dries instantly under ultraviolet light. This paint contains silver and becomes the defrost circuit for the backlight. The paint room accumulator holds 75 painted backlights. This operation positions the backlights on the Lear conveyor. The silver paint will be cured by the heat of the Lear. This Lear is an electric roller hearth, distinctive for the 200 ceramic rollers that transport the backlights. At the end, the glass is picked up by a vacuum pressure and dropped into the shuttle carrying a bending frame. Cool air quenches the glass and sets the form. Compressed air from the bottom pushes the backlight up off the bending frame. This cooling conveyor brings the temperature the rest of the way down. This finished product will be sent into the pigtail operation 50 feet away. The term pigtail refers to the wires that will connect the painted silver lines in the backlight to the car's electrical system. This operation actually attaches the clips or connections for those two wires. A buffing wheel roughs up the surface. A jet of hot air solders the clip onto the silver painted surface. The final station checks the circuit and solder weld. This finished product will be sent to either Chicago or Atlanta and becomes part of a Ford Taurus. The 700 series line is a newer version of the previous line, the 600 series. Both produce backlights. The technology is substantially the same. The NC cutter station, flame stripping. The grinders are numerically controlled models and can handle larger products. The Unimate robot serves the purpose of loading and unloading the two grinders. The advanced washer was engineered as a team effort in the plant. The cut and grind accumulator has a capacity of 71 pieces. The paint room features complete backup painting assemblies that can be rolled into place. A new lift system raises the backlights to the Lear conveyor. This is also a roller-type Lear. The quench features a quick change form for product changeovers. The quenching process sets the glass to break into fragments. The federal standard for this type of safety glass is no larger than 4 1/4 grams per piece. Every 30 minutes, a backlight is tested for the break pattern. Windshields are made in the departments in the 300 series. The first stop for windshields is the cutting department. These 6 cutting lines are near the cafeteria. The NC, or numerically controlled cutting table, scores the bracket or stock without the aid of a physical template. The glass is conveyed to flame stripping, where the trim is heated, and breaks at the score marks. The trim is dropped onto the cullet conveyor, and the cutout template is conveyed to the edge grinding or seaming operation. Diamond wheel seamers remove the sharp edges of the upper and lower surfaces of the template. A rotation device spins the template for the next seaming operation. Now all 4 sides have been seamed. A hot water washer is used to clean the template of glass chips and cutting oil. The washer delivers a dry template to the inspection station. There are 6 cutting lines for windshields, and 4 will be in operation at any time to meet the demand. One windshield is actually made up of two pieces of glass sandwiched together and held by a vinyl film. The outside piece of glass is cut slightly larger to compensate for the bending curve, so that the sandwiched edges match up evenly in the finished windshield. There is a short or inside template and an outside or long template. The templates are trucked over to the main windshield line. This large area for windshield cutting is separated from the rest of the line, which continues here at the center of the building and extends almost to the other end of the plant. These two robots load the short ends into a central paint room. The short ends pass through a pre-paint washer and into the paint room. The silk screen painting system floods the surface with paint on one stroke. On the second stroke, the squeegee forces the paint through the pattern in the silk screen. Meanwhile, the long end has come around the corner of the building where they will meet at the pairing station. A supply of pairs is ready to feed the line when the paint room does routine and emergency maintenance work. The leer is a furnace where the glass is heated and bent to shape. A loading shuttle places the pair onto a metal frame for the ride through the furnace. The temperature reaches 1100 degrees in a series of steps or zones of temperature. Each pair is unique in the exact pattern of the bend. If one is damaged, the other is unusable. The pair is separated and flipped over for the next washing station. A final wash before the lamination room. The long end comes through first and then the short end. The vinyl is positioned and the long end placed on top. The trim is removed and recycled. The sandwich is heated in an oven briefly to warm the vinyl. The air is squeezed out by the rollers. The same process is repeated at a higher temperature. The second set of rollers seal the sandwich closed at the edges. The mounting bracket for the rear view mirror is attached here. The windshields are grouped onto racks and taken to the final process, the autoclave. The autoclave is like a pressure cooker for 12 racks of windshields at a time. At the other end, the 12 finished racks are pulled out automatically. The rear door is cranked closed to seal the next group. It pressurizes to 250 pounds per square inch and heats to 250 degrees Fahrenheit. The pressure removes any air left in the sandwich. The heat turns the vinyl from frosted to clear as it bonds the pair together. The result is a finished product. The windshields are mounted on a conveyor for final inspection.